With statics, we are going to be looking at the first aspect of statics is beams and cantilevers. So with beams, we are going to be looking at different kind of loading. The concentrated force and the UDL, uniformly distributed load. And then we're going to be looking at how to draw a shear force and a bending moment diagram. Those of you guys that came from N3, this has been done in N3. I believe it's still the same principle here. So I'm just going to start with some few explanation here. So statics, when we talk about static is a branch of mechanics that deals with the forces acting on a rigid body. Like the beam now is a rigid body. The body are in static equilibrium. So you can see that there are some pictures here you can see. So the concept of statics is what is used in designing these bridges that you are seeing, these structures that you are seeing here. So engineers, mostly structural engineers, they use the knowledge of static to design structures. So it's very important for you to know the reason why you are learning a particular concept. So, so the reason why this knowledge is relevant is to design a structure that will not collapse after a period of time, and to also ensure that the structure remain what? Statics. So I wrote here, I said, this is the continuation of beams and shear force done in what? N3. So I'm going to be moving to the next slide. For simply supported beams and cantilevers with point load and the uniformly distributed load. So when we talk of a simply supported beam, this is a beam that is supported at each end. We all know this. And the load is allowed to distribute along its length. So you can see there is an example here, and there is also a practical picture that is shown here. So you can see the support at this point, and at that point. So when we talk about a uniform beam, a uniform beam is a beam that the area is constant along its length. So that is a uniform beam. And another thing here is concentrated load. Another word for this is point load. Point load or concentrated load. It means that it's concentrated at a particular section where it is acting. So a beam, for example, this is an example of a concentrated load. And with UDL, there is a load that is continuous, and this spreads over the length of the beam. So with UDL, you will be given in newtons per meter. So that's the load per meter. So this is where you have to multiply that value by the length for you to get the concentrated force there. So when you are taking your moment, you will have to use a concentrated force, which is the product of the load, per meter length multiplied by the length. You will get that concentrated force there. So when you are taking your moment, so the concentrated force will be taken into consideration. There are principles and laws that are used in doing calculations here for a simply supported beam. I've highlighted them in blue here. The upward forces and the downward forces must be equal. So our main aim here is to achieve equilibrium. That is for stability. And the sum of clockwise moment and anti-clockwise moment must be equal. So the sum of clockwise moment about any point or support is equal to the sum of the counterclockwise moment about the same point. I believe we all know how to take moment. Moment is force times perpendicular distance. So the force being the concentrated force multiplied by the perpendicular what? Distance, which is represented by what? By S. So these are the this is the concept. We're looking at the first section of this. Um, we are going to be moving to the calculations now, but I'm going to be testing you first. With this question is 7 marks. Um, we're told that a beam that is 8 meters long, the beam has a mass of 750 kilograms at its ends. So the end of A and the end of B. So that is where the reaction will be. They said a force of 600 acts vertically on the beam 2 meters from A, that has been indicated here, and a force of 1,300 Newton acts vertically at a point 6 meters from A. So if this is 2 meters from A, this will be 4 meters. And you must take into consideration that sometimes you will not be given the diagram. You will just be given the problem, and then you will have to construct the beam yourself. And if your beam is not correctly designed, you will get a wrong answer. Okay, so here you have to calculate the reaction RA at this point and the reaction to support B, which is RB. I want you guys to try this with the knowledge that you had from your entry. Calculate the reactions. Who is finished? I'm sure this is similar to what you have been doing from entry. Okay, let me show you a simple method of doing this. We want to calculate this reaction, RA and what? And RB. According to the concept, you can either take moment, you take moment about a support, or they call it fulcrum. So you can either take moment about A or you take moment about B. So that you work from the left to the right or from the right to the left. You still get the same answer. So I'm going to be working I like to work from the left to the right. So I'm going to be taking moment about B. Summation of moment about B equals to what? 0. Now the second thing I want to do here is to determine my clockwise and counterclockwise moment. So I'm taking moment about this support, and I want you guys to see something here. The weight of the beam is also a force that is acting. I've calculated it here. 7357.5. So if I want to take moment about B, it means that I want to calculate my reaction at A first. I'm working from the left to the right. So this is a clockwise moment, 600 counterclockwise, 1,300 counterclockwise. I'm taking moment about B. This weight is going to be what? Counterclockwise as well. So clockwise moment is equal to counterclockwise moment. Okay, so now let's do that. So this is going to be RA multiplied by, they said the total length of the beam is what? 8. It's 8 meters long. So if this is 2 and this is 4, that is 6. It simply means that the distance from that point to this point here is going to be what? It's going to be 2 meters. Because they said it's 8 meters long. So it's going to be RA times 8, which is the length, equals to the counterclockwise moment 600. It's going to be 600 times what? 6. 4 plus 2 is 6. Plus 1,300. Let me pick that one first. Multiply by what? 2. Then plus 7357.5. Multiply by what? is going to be multiplied by 4 because that is the weight. The weight act at the what? At the center. The whole length is 8. Half of that beam is 4 meters. So you can get your force reaction here as 8 Ra. You have to give me the values of this. If you can punch everything together and give me the value there so that I can calculate my R reaction at A. 35630, right? Point what? Not point something. Divided by 8. Use a shorter method. Use a longer method. Oh, okay. This one is that's why I mentioned the principle here. The sum of clockwise and counterclockwise moment will allow you to. Now, how do you get the reaction at B? You don't have to take moment. Just use the summation of the upward forces is equals to the summation of downward forces. This is the principle that I'm using here. Upward and downward force the same. So which ones are the upward forces? The upward forces are the reactions Ra and Rb. So we already calculated Ra to be 4453 point what? 75. We are looking for Rb. The downward forces are 600. We're just gonna squeeze that here plus 1300 plus the weight, which is what? 7357 plus 5.5. So this is going to be 4453 plus the reaction at B. Can someone sum up all this? So my reaction at B will be equals to 9257.5 minus 4453. The reaction at B will be what? That is our answer. This is the reaction at A. This is the reaction at what? At B. Okay, I want you to add um, both reactions together. Add all the upward forces together and add all the downward forces together. It must be equal. Equal, right? Yes. This question we are doing is actually easy. Let's look at the one that has a combination of. So in that question two there we have a uniformly distributed load of 130 newtons per meter. I know a lot of students normally struggle with this aspect of beams, right? How to take moment, isn't it? A lot of students normally struggle with this aspect, how to take moment and how to draw shear force and bending moment down. But you get it right now. Let's look at this question. They said a beam, if you can solve it, you can also be doing something as well. We are given the mass of the beam to be 100 kilograms. They said it carries a UDL of 130 Newton per meter over its left. Okay, the diagram is there. It is supported 1 meters from the right, 1 meters from the left. The length of the beam is 7. Okay, calculate the magnitude of the reaction. The reaction forces are this R, L, I will put because that's the left hand side. And then I will say this is the reaction of the right hand side. I can't label it A and B because they already use the letter here. I want you to look at something here. They said this UDL. Now, when you see a uniformly distributed load, I was trying to figure out what length did this uniformly distributed load covered so that I'll be able to get the concentrated force there. So, because you see here from this statement, they said UDL of 130 Newton per meter over its left half. So, if the total length is 7 meters, it simply means that the length that is covered by this UDL is what? 3.5. 3.5 meters. Let me just write it here. So with that 3.5, I can get my concentrated force there. How do I get my concentrated force? They already said that this is 130 Newton per 1 meter. So for 3.5 meters, you multiply 3.5 by 130. 130 times 3.5 is going to give us what? 455. So I have a concentrated load there of 455 newtons. So I'm going to indicate that here. Let me just put that here. 455 newtons. So I'm going to be using this diagram. I'm going to be reading from here, going back and forth. Okay, we are also given the weight of that beam to be 980. So it's going to act exactly here because this is the half. It's going to give us, this is going to be 980 what? Newtons. That is the weight of the beam because I see it's 100 here. So 100 times 9.81, you give us 980 newtons. So what you need to do here with what I'm saying here is you are now going to take your moment. So these are the support right here, which is this is the left support and this is the right support. Okay, let me just write this. This is 100 times 9.81, 981 newtons. Now we are going to apply the same principle. Like I said, I'm going to be working from the left to the right. So the summation of moment to the right hand support equals 0. So I would say that clockwise moment is equals to counterclockwise moment. Clockwise is equals to what? Clockwise moment. Now let's take our moment. Now if I'm walking from the left to the right, it simply means that I'm going to get the reaction at the left hand side first. Let's identify how these forces are acting. So this one, that direction, which is clockwise, right? Now there is another point load here, which is 455. This is going to be the direction. This is clockwise. This is counterclockwise. And then the weight here is going to act in this direction, which is counterclockwise. So we have one clockwise and two counterclockwise. So how do I know? Sometimes, um, why didn't I draw this like this? These are some of the questions because now what determines whether I'm to draw in this direction or in this direction is that when you have a load and then you are taking moment about the right hand side of the load, now it's going to the it's going to be a what? It's going to be a clockwise movement because you are taking moment about this support. If you were taking moment about a support on the left hand side, it was going to be the other way around, counterclockwise. This is very important. Now, so let's write those things down. So we're going to have RL multiplied by what is the distance? Distance there is 5. Distance between the support is 5 equals to the other movements there, the forces there. We have 455. So this is going to be 455 multiplied by, it's going to be multiplied by what? I want us to calculate the distance from this point. What's distance from this point to this point? The distance from here to here is 3.5, right? So 3.5 minus 1 is going to give you what? 2.5. So from this point is 2.5, isn't it? 2.5 minus 0.5 minus 3.5 is going to give you what? It's going to give us 1. Yes, that should be 4.25. The other force there is 981. Distance from this point to this point is 3.5. So 3.5 minus 1 is what? 2.5. So now you can calculate your reaction. So this is going to be 5 RL. Someone should compute that for me. I want you to calculate the one on the right. So you just do upward and downward force, then you get the other one. I want you to calculate that. So it's still the same concept. The summation of the upward forces equals to summation of the downward forces. So the upward forces is RL plus RR. The downward forces is what? Is 981 plus what? 455. So you just substitute the value of RL inside here, and then you get the one for the right hand side. There's another way that you must use to check. Then after you got that, then you can check by summing whether it balances. Someone is raising up their hand. I was explaining something here. How I got 4.25. Okay, let me explain it. Now, remember the distance from this point to this point is 3.5, right? Because I said it's half, it covers half of the beam. Okay, and the point load is going to be acting at the middle. So 3.5 divided by 2 is what? Is 1.75. So from this point to this point is what? 1.75. You are taking moment from this point to this point. So you're going to add 1.75 plus 2.5 because the distance from this point to this point is 3.5. 3.5 minus 2.5. So you add 1.75 to what? To 2.5, you get 4.25. Did you get it now? You're spending too much time. Let's move on. Um, Question 3. I want you to try question 3. You are asked to calculate two things there. There is a force that you have to put on that beam to make it stable. You need to calculate the magnitude of that force and then at what position along the length that you expected to put that force to make that beam to be stable. Now to get the force is not difficult. The A part, magnitude of the load. Now we have been told that the weight of that beam, let's look at the center. We have been told that the weight of that beam is 120, so this is going to be 120. Weight is mass times gravity times 9.81. This will give you what? To give you 117 1177.2 what? 0.2 newtons. So what you just need to do here is the summation of upward forces equals to summation of downward what? Downward forces. So the upward forces is 980 plus what? 1200 equals to the downward force 1177.2 plus that force that has to be placed on the beam to keep the beam in equilibrium. We don't know that force. So let's add these together. So this will give us what? 1200 plus 2180 equals to 1177.2 plus what? F. So we can get our force 2180 minus what? 1177.2. It's just a matter of just applying the laws. 1002.8 newtons, or you can say 1003 newtons. That is the force that we are looking for, that will keep that beam in equilibrium. But where are we going to put that force? The position now. Where on the beam? Is it going to be in the middle? Is it going to be far right, far left? How do you determine that? Because they said the magnitude and the position of the concentrated load. So the concentrated load is 103 newtons. How do you determine that? I'm going to show you now. So we have a concentrated load of 1003 newtons. Let me label this A. Let me label this section B. So I'm going to take moment. I've been taking moment about B. So now I want to work from the right to the left. I've been working from the left to the right. So it means that I'm going to take moment about this support here. Let me indicate the load here. The load is 1177.2 what? 0.2 newtons. The length of that beam is 8 meters. So that will be 4. So 4 minus 1, that will be 3. Okay, let me take moment, summation of moment about the support A is 0. So now let's indicate our clockwise and counterclockwise moment. Okay, this one. Now because that load has to be placed somewhere on the beam, it's acting downward. So this load as well is going to be what? Is going to act towards the left. So that is clockwise moment. So we are now going to have our RB multiplied by the distance. What's distance from here to here is 5. It's going to be equals to 1177.2 multiplied by 3, because the distance is 8. Distance is 4 minus 1 is 3 plus 1003 multiplied by x. You see it now. So that x there is going to be the position. Now, RB is 1200 times 5 equals to 1177.2 times what? 3 plus 1003x. Can someone just compute this? Just give me the value of x, the position, because of time. -1. Yes. 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 Now, what does this mean? Okay, we got a position 3.462. Is it from the left or from the right? How are we going to measure it? Now, because we are taking moment about A, which is the left hand side, so it simply means that it is 3 point, that load will be placed there, 3.462 meters. That load of 1003 be there. If I had taken moment about A, what is going to give me now is that I'm going to measure that distance from the right hand side, from the far right, because I took moment about B. But because I took moment about A, I'm going to measure from that side. The question says that position of the concentrated load that will keep the beam in equilibrium. So it's 3.462 meters from the far left. So it simply means that the load has to be placed at 2.462 from support A. So you just subtract 1. So the distance from this point to this point here is going to be 2.46 what? 2 meters. So you can subtract 0.462 minus 5. It's going to give you what? 2.54. So it is 2.462 from A, then 2.54 from what? From support B. 2.5. I got 2.538. So 2.5, let me just write it, 38 meters from support B. I just subtracted 2.462 from 5 meters because the distance between the support is 5 meters. Do you understand? Do you understand? And then if you want to write the answer, you can write it in words. You can write it. Okay, the first one, the magnitude of the load is 1003. Where did we calculate that? Okay, the load 2.462 meters from support A and 2.538 meters from support B. This is how you leave your answer. So this is the position. So what the examiner wants to mark there is this, and also from which support, A or B. So here we've determined the load, and then the load has to be placed at those positions. Any questions? Let's look at question 4. Now with question 4, there is no diagram. You have to construct your diagram yourself. This is the last question we're going to be looking at. Then we'll go to shear force and bending moment. This is how your beam will look like. We check the question. The support at the left end is 1 meters from the right end. From the right end. So that's the 1 meter there. And they said it is supported at the left. So this is the support at the left. And the other support is 1 meters from the right end. Question says calculate the position between the support at which a concentrated load of 40 must be applied if the reaction in the two supports are equal. Position if the reaction in the two supports are to be equal. So what is that reaction? Now we know that summation of upward force is equals to summation of downward force. So the upward forces, they said the reaction is the same. So we can say that we can say RL plus RL equals to downward force is the weight 588.6 plus they said a force of 400 must be applied plus 400. So we can say 2 RL equals to that is 988.6 divided by 2 is going to give us 4. This is the reaction I'm saying. So the left hand side is equals to the right hand side reaction, which is equals to 494 point what? 0.3 newtons. So now the second one is the position about any point. We want to take moment. This is the A part, the B part. So now that we already gotten the reaction to be 494.3 newtons here, this one is also 494.3 newtons the other side. So we can take moment about the left hand side. That you take about the left or right is going to be the same. So summation of moment about the left side of the beam equals to 0. So I'm going to have 494.3 multiplied by 5 equals to, I have the weight there, 588.6 multiplied by 3, then plus 400x. We want to calculate that position. Hmm? Hmm? No, we are still calculating the position of this. Okay, let me name this not A and B, I and II. X 1.76 meters from the left hand side of the what? Of the beam. 1.76. It means the 400 newtons 1.76 meters. We'll continue tomorrow. You only have 3 minutes. I will solve the rest. The B part is also the same thing. So instead of you using 400, use 1000. So you perform the same operation here. You put 1000 here. You get your, it's the same condition. They said if the reaction and the support are to be equal. So it's the same thing. You get the reaction and then you take moment. So this will be 1000 what? X. The same process. Now the third one, they said the reaction, the right hand support. Okay, they said if the reaction, the right hand support is twice that in the left hand support. So with the C part, they said the reaction, the right hand support is twice that on the left hand side. So when you are doing your upward and downward forces, so you replace this reaction of R by this. So you get your left hand side reaction first. Remember, upward and downward force must be equal. I'll solve it tomorrow, but you replace that with twice RL for you to get your reaction. And then you take your moment. So B and C, we'll look at B and C tomorrow.